Hello everyone. In this video, we'll talk about the portfolio theory 2 and solve some questions from there. So the first question that we'll talk about is defining capital asset pricing model and outlining its assumptions. So we need to define this one. And while you answer this question, remember, we just give a definition of CAPM, just theoretical definition. And remember, you need to include the model. So you need to write down that RI equal to RF beta, RM minus RF. And you need to mention what RI means, RF, beta, and RM means. So what the mean, and also you need to include the underlying assumptions of that model. So if you give a little bit of theoretical history, that will be even better while answering the first part of the question. Now, if you want to go a little bit of extra with this, so while you answer the second part, the underlying assumption, probably you can actually criticize those assumptions. So the different scenarios, so when these assumptions may not be valid. Second question is asking, as analyst and wants to evaluate portfolio X, Y, and Z, so portfolio Y, X, Y, and Z, consistent entirely UK common stock. So that's why we have the benchmark FTSE All Share using both Treynor and Sharpe ratio, looking into all of these details are given in this table. So looking into different last 5 ATS, that's the average annual rate of return and standard deviation, annual standard deviation of the return, and the beta. We're given the T-bill as a risk-free rate 6% and RM, that's the market FTSE All Share, as 12%. So what we need to calculate Sharpe ratio, Treynor, and Jensen alpha, and we can only use the Sharpe and Treynor ratio to compare with FTSE All Share. But if you want to compare X, Y, and Z, you can use the Jensen alpha as well. So you need to second part of the second question is asking to look into whether they underperformed, equaled, or outperformed the FTSE All Share. So in this way, we only need Sharpe and Treynor ratio, but is asking to calculate Jensen alpha as part of question A. And as an extra, we got looking into, this is something that I think is important to look at, is to why the different measures, when the different measures are appropriate in different situations. So you could have a different situation. So when Sharpe ratio is better, or Treynor ratio is better, or Jensen alpha is a better measure in terms of evaluating portfolio performance. Now, I pre-populated this table in the exam. You need to do this one for yourself. So what we have, we've converted everything in decimal, and let's say we want to calculate, let's put 3 different one in here. So want to calculate the first one, probably just put Treynor Sharpe ratio and Jensen, and then probably we can just the Sharpe ratio, a Treynor ratio, and this Jensen alpha. And let's look into, let's put a little bit more space here though. Probably need a little bit more space. So let's do the formula. So what formula, the formula we have? So we've got Ri minus Rf divided by sigma. So this is Rp because we're looking into portfolio. So this is the Sharpe ratio measure. Let's put a little bit up. And if we put this one RP minus RF divided by beta, that we got the Treynor ratio. And Jensen alpha, we know this is RP minus the expected RP. And instead of expected RP, what we need to write is the CAPM. So RI plus beta, RM minus RF. Now, let's look into portfolio X. What do we have? In portfolio X, we get RP, which is 0.10. So this is RP, and this is sigma P, and this is the beta, right? So we've got 0.10 minus RF. RF is 6%, so 0.06 divided by sigma P, which is 0.18. And if we do these maths, we got this one, 0.22. And for Treynor ratio, this one is 0.1 minus 0.06. Instead of 18%, we need to write down, instead of sigma, we need to write down beta, which is 0.6. And we get this one as 0.0667. Now, for Jensen alpha, we got the RP, which is 0.1 minus, now write down the CAPM formula. So RF, so my bad, this is RF, 0.06 plus beta, which is 0.6. RM, we got, this is RM, and this is RF. So RM 0.12 minus 0.06. And if we do this calculation, we got this one as 0.40. So let's do this one same for portfolio Y. We got 16 minus 0.06 divided by got 0.22. And if we do this calculation, we got 0.45. And numerator is going to be the same, 0.16 minus 0.06. And the beta for this is 1.2. And because we're dividing with the larger value, that value will come down to 0.0833. So, and let's look into this portfolio Z. We got 0.09. So my bad is 0.09 should be minus 0.06 divided by 0.1. And this one will give you 0.30. And so 0.9 minus 0.06 divided by the beta 0.7, and that one 0.0429. And for FTSE, you need to calculate this one as well because you want to compare. And so this is 0.12 minus 0.06 divided by 0.13, which is his standard deviation. And this is 0.46. Though that one is 0.12 minus 0.06 divided by, because the beta of market is always 1, and this is give us 0.06. If I calculate this portfolio X, that Y, the Jensen alpha, so this is 0.16 minus 0.06 plus, only the beta here will change, 1.2, and a market excess return is the same for both. And this will give us 2.80. For portfolio Z, this one 0.09 minus 0.06, which is the risk-free rate, beta 0.7, and 0.12 minus 0.06, that will give us a negative 1.2. 0. So now, if I want to, for example, looking into which one is performing better, so let's look into a Sharpe ratio. The bigger the better, right? So if you're looking into the Sharpe ratio, just put this one in a different color. So if you're looking into the Sharpe ratio, so we're comparing 0.22, 0.45, 0.30, and 0.46. So we can see all of them underperformed. So X, Y, and Z, all of them underperformed. So we can just write a comment comparing this one. All of them. So we are actually answering the second question of B. All of them underperformed. Now, if you're looking into these, the Treynor ratio, let's say which one is a bigger number. So 0.6, this is bigger number, right? So this is overperformed. This is a bigger than compared. So we are comparing with this value, right? So we're comparing with the market Treynor ratio. So I can see X and Y outperformed. However, Z underperformed. Now, we can compare Jensen alpha with each other, not with the market. So if we compare Jensen alpha with each other, which is not in the question, but maybe it comes in the exam that you compare with Jensen alpha, we can see portfolios Y is better, and this is number 1, and this is number 2, and this is actually making less. Its alpha is negative, so it's giving us less return than taking all of this risk. Now, let's look into define and discuss so Sharpe ratio Jensen measure. So when you're looking into the defining in, so we need to just define, put all of this in the formula and what actually those formula refers to, and explain the situation in which each measure is better. Now, if we're looking into these, the Sharpe ratio, what Sharpe ratio is doing, so it's RP minus RF divided by the sigma P. Now, the sigma P is actually a measure of total risk. So as we can say, because it's just telling us how much this is excess return. So this is excess return. How much is the excess return we are making for each amount of total risk? So this measure is appropriate for a portfolio performance evaluation if the portfolio that we are evaluating represents the investor's complete portfolio of. So this is all of the total the portfolio. Now, the Treynor ratio looking into RP minus RF divided by the beta. Now, beta measures the systematic risk, right? So, because it's looking into what is our excess return per amount of systematic risk that we are taking. So this measure is appropriate. We're talking about the Treynor ratio. When we want to do a portfolio performance evaluation in the scenario where the portfolio that we're evaluating in only a small part of the large investment portfolio. So the part of the portfolio. And is also appropriate when you're looking into sub-portfolio of a large funds. For example, if you're looking into if a manager covers a lot of portfolio, so the sub-portfolio of a large fund, such as the pension fund, if you want to measure. Now, Jensen alpha, if we're looking at RP minus RF beta RM minus RF. So what is actually looking at? So this is CAPM. So CAPM is telling us what is our expected return with all of these, the risk. What are those risks? The only risk measure is in here, the beta. So after taking all of the risks, how much we are getting extra, right? So RP minus our expected. So what we are expecting minus what you are actually getting. Now, this measure, which is a same measure, similar using the systematic risk, but the applications are a little bit different. So it's appropriate if you want to measure, for example, a manager's sub-portfolio. So if you're comparing, for example, portfolio X, Y, and Z, not comparing with the market. So we're looking into comparing the performance of a different portfolio or a performance of a different manager. We can look into this Jensen alpha when it tells us the larger the value, that means larger their skills. So also, if you want to, for example, measure performance managers' skills, or you can say measures performance of a different portfolio. So we are checking. So by selecting those particular companies in that portfolio, how much it is generating top of what we are expecting, right? You can find out the details answer in the book, and hope this video helps you to understand all of the concept. Thank you for watching.